Hey guys, welcome back to the DAHKTUBE. And before we get started, don't forget to like, share, comment, and subscribe. Now today we'll be doing relations and functions. So the first aspect we're doing is relations. Now a relation is a set of ordered pairs. Now for each ordered pair, it is a point which are in coordinates x and y. So now we have our x values, which are called our input, or you can call it your domain. Then you have your y values, which you can call your output or your range. Now, for example, let's say we have y is equal to 3x plus 1 for x such that x is in the range -3 to +3, where x is in integers. So it is important for you to know integers, rational numbers, irrational numbers, whole numbers, natural numbers, quote unquote, all your real numbers. So you need to know the different numbers that fall within each category. So now we're going to draw an arrow diagram to represent this here. So we have y is equal to 3x plus 1, and we set of x values to be -3, -2, -1, 0, 1, 2, and 3. So we can drop a little table. That means now we'd have our y's. So that means anywhere we see x in this equation, we're substituting -3, -2, -1 so that we can get the corresponding y values. So when x is -3, y is going to be equal to -8. When x is -2, y is going to be -5. When x is -1, y is going to be -2. When x is 0, y is 1. When x is 1, y is 4. When x is 2, y is 7. And when x is 3, y is 10. So we can now actually draw our arrow diagram based on these input and our output. So we have x here, which would be -3, -2, -1, 0, 1, 2, 3. And we draw that. Then we have y, and we have -8, -5, -2, 1, 4, 7, and 10. And we draw this here. So what this is saying is that each input or domain has a corresponding output or range. So this maps to this here, this maps to this here, this to this, this to this, this to this, this to this, and this to this. So it's saying x is mapped to 3x plus 1, which is the same thing as saying y is equal to 3x plus 1. So now we have the set of ordered pairs. So a while ago we had -3 corresponding with -8. So that means the set of ordered pairs is going to be -3, -8, -2, -5, -1, -2, 0 and 1, 1 and 4, 2, 7, and 3 and 10. So that would be a set of ordered pairs. Now your ordered pairs have to be in curly brackets with the round brackets on the inside. So again, the domain consists x coordinates, inputs, objects. So those are the terms that you can use: x values, inputs, domain, objects. So it would be -3, -2, -1, 0, 1, 2, and 3. Then you have your y coordinates, range, output, or image for this one. And it would be -8, -5, -2, 1, 4, 7, and 10. Then you'd have your codomain. So the codomain, all elements where the images are contained. Now you might have, for example, 5 elements in the y aspect, but not all elements might be mapped to something in the x. So let's say 3 elements are mapped to something in the x. The 3 elements that are mapped are called your range, but the 2 that are not mapped, along with the 3 that are mapped, are your codomain. That's why the range is a subset of the codomain. So now we're going to do types of relations. Now we have the first one here, which is a one-to-one. So each element in the domain is mapped to a unique element in the range. For example, let's say we have x and we have y. Let's say this is 1, 2, 3. And let's say this is 4, 5, 6. So one-to-one means that each element in the domain is mapped to a unique element in the range. So one thing is mapped to one thing. So a one-to-one. That's what it looks like. The second one we have here is one-to-many. So each element in the domain is mapped to more than one element in the range. For example, let's say we have x, which is 1 and 2, and y, which is 3, 4, 5, and 6. So each element in the domain, so for example, this one here, is mapped to more than one element in the range. So it goes to, for example, 3 and 4, and let's say 2 goes to 5 and 6. So that's one thing going to more than one thing. So one-to-many. So the third one we have is many-to-one. So multiple elements in the domain is mapped to the same element in the range. For example, let's say we have x, and let's say we have 1, 2, 3, and 4. Let's say we have y, which is 5 and 6. So this goes to this goes to this goes to this, and this goes to this. So multiple elements in the domain, so 1, 2, is mapped to the same element in the range, 1 over here. So it's many things going to 1. So the fourth one we have here is called many-to-many. So multiple elements in the domain is mapped to multiple elements in the range. Let's say we have x and y. Let's say this is 1, 2, 3. And let's say this is 4, 5, 6. So 1 here goes to 4, and 2 here goes to 4 as well. Let's say in the same breath, 1 goes to 5, and 2 goes to 5 as well. So 1 and 2 are both going to 5, and 1 and 2 are both going to 4. So many elements in the domain are going to many elements in the range. So that is what many-to-many means. So now we'll be doing functions. So a function is a relation in which each element in the domain is mapped to exactly one element in the range, with no x value being left unmapped. Now, this is how we write. So we can say f x 3x plus 1, or we can have f of x is equal to 3x plus 1. So these are the two notations that we can use to represent a function. So the first thing we're going to do here is injective. So a function is injective, which is the same thing as saying it is one-to-one, if each element in the domain is mapped to a unique element in the codomain. So a function so for all x1, x2 in X is injective if part I, x1 not equal to x2, which implies that f of x1 is not equal to f of x2. And 2, f of x1 is equal to f of x2, which implies that x1 is equal to x2. So these are the criteria for if a function is injective. So this symbol here means for all. This here means element of. So the next thing we're going to look at is surjective. So a function is surjective, which is onto, if each element in the codomain is mapped by at least one element in the domain. That's saying a function if f of x equal y, that means your range is equal to your codomain. So for all y in Y, there exists an X in the set of X such that f of X is equal to Y. So now for bijective, a function is bijective if it is both injective and surjective. All right, so let's say we have this question here. Determine if f of x is equal to 2x plus 5 is injective, surjective, bijective, where x is in real and y is in real. So your answer would probably be totally different if x was just in the set of integers or in the set of positive integers. So you have to focus on what are real numbers so that you can answer the question effectively. So let's try to see if it is injective. So in order to test if it is injective, so we have f of x is equal to 2x plus 5. So you want to choose two values. So for example, let x1 be equal to, I don't know, 2, and let x2 be equal to, let's say, 3. So you just pick two random numbers and you substitute them into this equation. So for x1, that would be f of 2 is equal to 2 times 2 plus 5, which would be equal to 9. And f of 3 would be equal to 2 times 3 plus 5, which would be equal to 11. So as you can see here, x1 is not equal to x2, and that implies that f2 is not equal to f3. That means it is injective. So now we're going to test if it is surjective. So now we have f of x is equal to 2x plus 5. First thing you want to do, interchange f of x with y. So you want to say let y be equal to 2x plus 5. Now you want to make x the subject of this formula. So you have y minus 5 is equal to 2x. That means y minus 5 over 2 is equal to x. Now because it says that x is in real and y is also in real, let's say we want to try when y is equal to 0. So if you put y 0, that means x is equal to negative 5 over 2. So let's say y is equal to 1. That means x is equal to minus 4 over 2, which is minus 2. Let's say y is equal to minus 3, for example. That means x would be equal to minus 8 over 2. So x would be equal to -4 here. So as you can see, this is a real number, real, real, real. And so therefore, this is surjective. So you have to focus on the range and you have to focus on if they're in reals, integers, etc., etc. So that means it is bijective since it is injective and surjective. So that's basically all we're going to be doing today. Thank you guys for staying tuned, and don't forget to like, share, comment, and subscribe. I'll see you guys next time on the DAHKTUBE.